So tell me a little bit about yourself and your background in IoT.
Sure. My name is Hima. I work for GE in the group of GE called GE Digital. My responsibility at GE is to run the engineering organization that builds Predix. Before I did this, I used to work at Sybase, and we got acquired by SAP, where I was building mobile platforms. Predix is the industrial IoT platform, which is geared towards enabling industrial applications to be deployed, built, and orchestrated in a large scale.
Now, first of all, contrast the difference between M2M and IoT.
So the way I look at it is M2M is an integral part of a large IoT, industrial IoT platform. So M2M, as it stands, machine-to-machine communication. And if you look at any industrial use cases, if you think of a wind turbine, there's a lot of wind turbines that are operating in a wind farm. So to control a wind turbine farm, each of the wind turbines need to talk to each other.
Right.
So the controllers in each of the wind turbine talk to each other, trying to decide which way should the pitch of the blade go. So M2M is an integral part of an IoT, industrial IoT platform. Contrary to that, a simple IoT platform, because they target smaller sort of assets, smaller sensors, there's no need to have this inter-sensor communication a lot. So M2M is very integral to an industrial IoT to enable this machine-to-machine communication and then enable that data to be controlled and diverted and stored in the cloud environment. And that's where the other part of the IoT platform comes in.
So you're saying then the difference between an IoT platform and M2M is this communication of moving the data then over to the cloud?
So the essential part of M2M is to connect the machines and make them talk to each other, and especially when the machines are, in the industrial space, the machines cannot speak IP. They speak this old protocol. So M2M is all about how do you enable these sensors and the assets to talk to each other, dealing with some of these networking protocols that are not IP based, and some of them go back to physical protocols, right? Physically hardwired. So M2M is essentially about that, and then it feeds the data into the rest of the IoT ecosystem, which is about data, which is about processing, which is about analytics. Okay. Right?
Okay. And I mean, there's a lot of different definitions, but what is your definition of an IoT platform?
In my view of IoT, and I'm going to talk about IoT generally and then narrow it down to industrial IoT.
Right.
IoT as a platform is to enable sensors to collect the data, push the data into cloud or in a data center, do some data processing. It could be big data, it could be small data, it doesn't matter, and then run some analytics on that data set and deliver some outcomes to the customer.
Right.
Essentially, that's what IoT would boil down to. If you take the technology out of the picture, what do you want to do with an IoT platform? Fitbit. You're trying to tell someone how much have they exercised. Contrary to that, or not contrary to that, but narrowing it down, in the industrial space, what we focus on is connecting to industrial assets,
right,
and then getting larger volumes of data. One of the differentiating things when I look at a pure IoT and an industrial version of the platform is the scale of data is so unique. The velocity of the data is so different, and the variety is so different. What we care a lot about is sort of time series.
Right.
What was the reading on a particular sensor, a temperature sensor or a pressure sensor on a turbine at any point of the day or the night when it's operating.
Right.
And then collecting that scale of data. An example of that is a wind turbine collects around 10,000 terabytes of data in one day.
Wow.
Imagine there are 10,000 of these that GE alone makes.
So how many time slices is that during the day?
It could be collecting on a sub-second time slice.
Sub-second?
It could be collecting on a sub-second time slice. But what we don't force them to do is push all of that data into the cloud. So a lot of that gets processed locally so that some local analytics run for computing model. And we've done this for some time, not in a very unstandardized format. And that's where the platforms come into play, where you're trying to make this a lot more standardized.
Okay.
So you want to do some local data processing, and you don't want to send all of that data because these guys are working in a disconnected remote environment, sometimes on satellite.
Right.
And if to send all of the data stream into the cloud over those low-speed networks costs a lot of money. So that's why this notion of fog computing, edge computing, to do some local analytics, decide what data is relevant, and then push the right amount of data into the cloud,
Okay.
so that cloud becomes the aggregation point. A wind farm running in place A, a wind farm running in place B, all of this data gets aggregated, and that's the purpose of running these analytics in the cloud.
Okay.
And so that's where the narrowing down of the industrial focus comes into play, which is the scale of the data. And then finally, it's the outcomes that are trying to be delivered. These outcomes depend on understanding what that asset is. It's very hard to understand a locomotive which has a million parts in it. So when you try to optimize the lifespan of a locomotive, you need to understand all the million parts that exist, and also understand the lifing models of each of those parts. And so that's where industrial IoT gets very specific to understanding the physics and the data and the analytics behind the assets, and then sort of connecting into these assets that are running in the field that don't talk IP, don't talk different kinds of protocols.
Okay, so what I think I hear you saying is that the platform is going to be talking to these OT networks.
Yep.
And there might be a gateway in there to do the translation between those protocols you were
Yep.
talking about,
Yep.
getting it up to the cloud, and then
Yep.
beyond that is actually running analytics on
Yep.
it. But what's important, what you said, is also modeling the particular industrial application.
Yeah,
In the case of that locomotive, then
Yeah.
you're going to need a very specific system to be able to model
Yeah.
the locomotive system. Is that,
Yeah.
am I getting it right?
Yeah, so we typically use a word called digital twin.
Yes.
A digital twin represents a virtual model of a physical asset, and the way we look at it is to deliver the outcomes, and the outcomes could be two. One, how do you prevent unplanned downtime? Two, how do you increase the productivity of a system?
Right.
And to do that, you need this notion of a digital twin, which
Right.
is a combination of a virtual model,
Yes.
a physical model of the lifing of the asset.
Right.
Three, the data science or the analytics-based models. And four, the actual data that's coming in from the real devices
Right.
or the real assets.
Right.
So this digital twin that runs inside the system, inside the cloud, and gets extended into the edge, gives this outcomes that we care about, and that's the purpose of an IoT platform.
Yeah, and I would even extend it a little bit more and say the application as well, right?
Yeah.
So you need the application that's running on this virtual twin or this model that you were talking about.
Yeah.
Yeah, and what's different a little bit is, we're used to functional models, for a long time, but this is more of a value model. It's more of a result-based model.
Absolutely.
And so you're modeling something a little bit more unique with IoT.
Exactly, and so that's how we actually react to, and customers, especially the industrial customers, react well to that way of looking at a solution. Because IT, everyone understands technology,
Right.
but industrial customers always look at what's the value that I get,
Absolutely.
and the way they look at the value is, am I getting more productivity out of the asset that's already deployed,
Right.
or am I reducing my unplanned downtime?
Right.
Right.
So top line or bottom line
Exactly.
savings on the P&L.
And that's why having this virtual digital twin to make those decisions, and the applications that use the digital twin to leverage all the data and analytics so that the value could be delivered to the customers.
Yeah.
That's what it boils down to.
Yeah, no, and I think that's very important. And the terminology I use is a software-defined product,
Yeah.
as opposed to the hardware-defined.
And so
product.
interesting you say that, because the edge side of it, we actually call it software-defined machines.
Right. And so that is on the data capture side.
It's on the just the same way the IT side of it has been transforming itself into software-defined landscape, software-defined networking,
Absolutely.
software-defined data centers.
Right.
We look at this edge as creating a software-defined machines where you have a virtual model of the of the asset. You need a virtual model also at the edge, so that the local analytics that are running can use that virtual model.
Right.
So it's no longer the actual asset itself.
Right.
It's also a software version of that asset that's running there, so that an analytic developer can
Yeah.
use that model to understand what parts exist in the asset and what are the relationship between the different parts.
Yeah, and I think you bring up a good point, is that you're contextualizing the data with
Absolutely.
this software-defined machine, as opposed to just sending, these numbers and then having to
Absolutely.
do some sort of lookup table or translation in the application.
Absolutely.
Yeah. Well, I'd like your opinion on buy versus build versus rent. What are your thoughts for an IoT platform?
It's an interesting question, because when we looked at how do we deliver the best value to a customer, today it all depends on how much data do we have, and I think it was Larry Page or someone who said from Google, our value is in having access to so much data so that we can make better decisions. In the in similar model, we can deliver better outcomes to predicting when the part may fail, when we are able to operate or do the analytics on a data set that's coming from not just one turbine, hundreds and thousands of turbines.
Right.
And how do you make that happen? It's got to be in a cloud. And so we sort of gravitate more towards delivering these outcomes based on a cloud deployment model. But we understand there are restrictions in some cases, utilities and other industries. What we don't want to do is redo the infrastructure, redo the services that developers can use differently because it's on-premise versus cloud. So we sort of look at it as a hybrid approach where give them the same sort of development and deployment model, but then constrain the access of the data, constrain the access of applications based on the policies that they have, and then sort of separate the infrastructure between cloud or managed deployment or on-premise deployment.
Okay.
So the way we look at this is it's always driven by the scale of the outcome you want to deliver. If the scale of the outcome is small, it's okay to build it yourself or buy it and then deploy it on your premise. If you want to leverage the networking effects of all the assets sending the data to a centralized place, then leverage that by going into the cloud and become part of the cloud.
Right.
That's how we look at it.
Yeah, no, and I think that makes sense. In the sense, what you're saying is that if you're gonna be using a lot of cloud, you can build a little cloud yourself. But then but managing a little cloud is a lot different than managing a big cloud that has a lot of sources of data.
Absolutely, and the scale of data I talked about, and let me give one more example, which is aviation. Aviation, every flight, the new 787, it collects around half a terabyte of data. Imagine if you want to build such a system by yourself, how much storage would you need?
Right.
And if you're only dealing with storage for peak situations, you end up doing a lot of underutilization. I'm speaking about the intrinsic values of cloud, but they also apply here.
Sure.
And they get sort of extended because of the scale of the data and the scale of the compute you would need in such scenarios. So it all depends on what is the scale of the outcomes you're trying to sort of deliver to yourself as an enterprise or to your customers when you're building applications.
Yeah, no, I think that's a good way of looking at it. You know, if you're, for example, if you're maybe starting, but then maybe this brings up a good question. What if you're just early prototyping? Are you suggesting that you don't use a platform and that you kind of develop it yourself, or should you still use the platform?
I think
because this can be small data.
Yeah. So the way I look at this, right? I've done platforms for the last 18 years. There's no reason why someone should invent one other platform.
I agree.
There's enough in the world, and all the value comes from understanding your business and just focusing on writing that business logic, writing that analytic, and just leverage some platform, whether it's cloud or whether it's on-premise, it doesn't matter. Just don't go back into the business of how do I ingest large volumes of data.
Right.
Do I want to do that from scratch? No. There's Kafka, there is Hadoop that enable all of that. Don't reinvent those. Leverage the platform that's there, focus on the business value that's close to understanding your assets. Whether you buy that platform to install it on-premise or leverage that on a cloud architecture like what we do at GE, it depends on prototyping. Go to cloud.
Right.
It's so quick. Why does everyone go to AWS today? It's because it's so easy to get access to it and without having to invest to the CapEx.
Yeah. No, as long as the cloud has the right interfaces, to that semantic data that we talked about earlier, you're doing good.
Absolutely.
And I agree, and this audience will know that I advocate buying a platform because, like you're saying, the core competency of a company doesn't have to be in the plumbing.
Yeah.
You're not going to be, building the plumbing for your company unless that's what your company does. Like you said, is focus on the value. However, there may be certain circumstances where it is part of your core competency, I suppose, but it's very, very rare. And it makes no sense to reinvent the wheel, in my view.
And it's sort of similar to what we did at GE, right? We knew it was going to be a cross-cutting concern across all of the businesses. We have bought a lot of platforms. If you look at GE, right, every company in the
your customers
company
too
sells to GE. But then what we realized was there isn't a IoT platform, an industrial IoT platform that meets our needs. So we said, let's build it, right? The question is, it's a question of buy versus build. My leaning would be, just buy something because there's enough platforms. There's no not that much innovation that a small company can do.
Right.
The next layer of questioning is, do I buy it to run on-premise or do I buy it as cloud services? And that's where it depends on the scale of the outcomes
Right.
you want to deliver.
Right.
Yeah.
And now let's go a little bit further down, and the term of buying it is could also mean leasing it,
Yeah.
right? Not
Yeah.
necessarily, so making it or not making it yourself. Buying it is one business model. Let's talk about the business models now, and let's talk about the leasing or the renting, the renting model. Can you maybe scope out just for our audience, what are the parameters here in terms of size, in terms of cost, in terms of what are people looking at?
Yeah, so it's an interesting place right now in how we are pricing cloud services. And gets more interesting in the industrial space, in the IoT space, because you got to look at one parameter could be how many assets are you, data from how many assets are you ingesting. One parameter could be how many analytics are you running. And so the way we look at pricing and the market it's evolving is you got to price your services like Amazon does in terms of the services that are being utilized. And so you got to break them down narrow enough so that the platform pricing is not the old school enterprise pricing, you pay $1 million, or even subscription model, you pay $100,000 a month and you get all the services.
Right.
You got to focus on what services do I need to do my POC or to build an application. And then example of that is, we have a service that enables someone, a data scientist, to upload an analytic into the catalog and then run that analytic over a data set. And so the parameters or the meters that we sort of measure are how many times is the analytic running,
right.
and how much data is the analytic running against. And we would sort of, for an example, you can run like a fixed price model, you could run your analytic 1,000 times, and each run can use 1 gig of data.
Okay.
And we could price that on a monthly basis for $20.
Okay.
Right? And that analytic could be written in Python, MATLAB, and that's where the platform comes in. You don't have to worry about it. The underlying platform runtime gets you that. The other way of looking at it is utility based, which is every analytic run costs you 20 cents, and then it's up to you to decide how many times. Right. And so it all depends on how you think you're going to consume a platform service. And then the more interesting thing is, I don't think we have found out the right pricing strategy, and I don't think anyone has. So having this dynamic pricing model, and we refer to this term as business operations. How do you put a good business operations behind the services model, where every time a price needs to be changed by a revenue manager or a marketing person, she or he doesn't have to work with the engineer. It's built into the platform to change that pricing model dynamically. It's sort of like I refer to this as A/B pricing. Like an A/B testing, A/B pricing, so that you send different users to a different pricing model, and then sort of experiment with the right pricing strategy, and then dynamically change it.
Right. Okay. Yeah. No. And I think that's right. So what you're saying is there can be an all-you-can-eat model, which is like a lease, or a pay-per-use model, maybe a little bit more practical.
Yeah, absolutely.
And then you just have to define the metrics that you're basing it on. So for analytics, what you're saying is number of times you run it, or the function of number of times you run it, and the size of the data model. For something else, it might be on metering, how many bytes go by.
Absolutely.